Okay, so the question states here, the photograph shows a demonstration of AC generator used in a school. The handle is used to rotate the coil between the magnetic poles when a light emitting diode LED is connected across the coil. The LED flashes on and off as the coil rotates. Explain this observation. A dot C is basically alternative current, right? So yeah, so when you rotate the handle, right, let me draw it first, then I'm gonna write the answer for you guys, right? So basically, right, when the coil is rotated, when you rotate this coil, you have this handle, right? I think so, yeah, this handle. When you rotate it, right, basically the magnetic field, basically the field created between the north pole and the south pole, imagine this is north pole, this is south pole, and then you have this coil right here, right? This is your coil. When you start rotating, the coil basically starts rotating as well, right? This thing also starts rotating itself, right? So there's like magnetic field lines from north to south, right? From here to here, north to south, right? This is north, this is south, right? So once you start rotating, basically it starts rotating in clockwise direction or anti-clockwise, is up to you. So I'm just saying that if you start to rotate in for example clockwise, sorry, anti-clockwise, my bad, anti-clockwise, so the magnetic field lines gets cut, they basically they're getting cut over here, right? So which causes magnetic flux linkage. Now basically magnetic flux linkage is not like a difficult definition. It basically NBA, magnetic flux linkage formula, right? So basically this is the number of turns, this is the magnetic flux density, and this is basically the current, right? So when this is the number of turns, coil, this is one turn, this is two turn, this is three turn, this is, they're counting as this is called magnetic flux linkage. When many turns get cut by the magnetic field, this is basically called magnetic flux linkage, right? So EM, now once they get cutted and they cause basically magnetic flux linkage, the EMF is induced, right? So you get EMF from it, right? And as we get EMF from it, and EMF can only flow if it's a complete circuit. For example, this is a complete circuit, right? For example, this is a complete circuit with a battery and stuff like that. You have a complete circuit, must have a complete circuit in order for the EMF or the current to or the voltage, current, anything to flow, right? So now the circuit will have basically a current flowing in it, right? Because of that current, basically because of the current, you're gonna make the LED start flashing. Now you wonder, like they said over here, the LED flashes on and off as the coil rotates. Why it's turning on and off, why it's not turned like fully on? Because remember, AC generator, they said AC generator in the first line, right? Their polarity always changes. They get from positive to negative on one side, and then they change it themselves and they become negative and positive, right? So basically they're changing the polarity of the the circuit, right? So one will be forward bias, right? One will be forward bias, forward bias, forward, and backward, right? Backward bias, and one will be forward bias, right? Let me write bias as well. Okay, so you have these two only in one of these way, because see, I have drawn basically a graph as well for you. This is a forward bias, this is a backward bias, this is FB, this is B, right? Backward bias, right? So only in one of these, or you can say reverse bias, backward or reverse, you can say another word which is reverse, it's not a big difference right there. Okay, so reverse bias, right? So basically only in one of these places the current will flow. If the LED is forward bias, means it only lights up in this region, then it will only shine on this region, and it will not shine on the reverse or backward bias, right? and it same goes for the other side. If it's like backward or reverse bias, it won't light up on the forward bias, right? So you just have to remember that. And let me write the sentence for you as well. So okay, so when the handle rotates, the magnetic field lines get cut, which causes magnetic flux linkage. So EMF is induced. As it is a complete circuit, so current will flow in that circuit. Now we have AC generator, so the polarity will change, meaning it will have a forward bias and a reverse bias. It depends on the LED which polarity it is. So one time it will flash and the other time it won't. So this is our answer.